Prepare to be astounded as we journey into the realm of cutting-edge agriculture, where innovation flourishes and traditional practices are reimagined. In this video, we reveal a captivating lineup of machines and tools that are pushing the boundaries of what's possible in farming. Brace yourself as we explore the wonders of vertical aquaponics systems, robotic dairy feed pushers that streamline cattle feeding, soil sampling and analysis equipment that unlocks the secrets of the land, plant disease detection sensors that safeguard crops, and automated grapevine pruning machines that revolutionize vineyard maintenance. Together, they represent a symphony of brilliance that is reshaping the landscape of modern farming. Number 5. Vertical aquaponics system. A vertical aquaponics system integrates aquaculture, also known as fish farming, with hydroponics, often known as growing plants without soil, in a configuration that is either vertically stacked or tiered. The cultivation of fish and plants together in one system is known as aquaponics, and it is a type of hydroponics. Beneficial bacteria in this system transform fish waste, which already contains ammonia, into nitrate, which may then be used by plants as a source of nutrients. As a result of the plant's filtration and purification processes, the water is brought back around to the fish tank for further use. A vertical aquaponics system makes the most efficient use of available space by stacking grow beds or plant containers in the vertical direction. This system enables a greater number of plants to be grown in a smaller footprint, which makes it suited for locations with limited space, such as cities or other areas with confined areas. Growing media that does not require soil are frequently utilized in vertical aquaponics systems. Common examples include expanded clay pellets, perlite, coconut coir, and rock wool. The roots of the plants benefit from the support provided by these media, which also allow for proper water movement and oxygenation. In vertical aquaponics systems, water management is of the utmost importance. The water from the fish tank is pumped up into the grow bed that is at the very top of the stack. This allows the water to slowly trickle down through the beds that are stacked below it. The plants take up the nutrients from the growing medium as the water moves through it, and the water that has been cleansed then flows back into the fish tank. Vertical aquaponics systems allow for the cultivation of a wide variety of leafy greens, herbs, and vegetables. Some examples might be lettuce, kale, spinach, basil, mint, strawberries, and so on. The types of plants that can be grown in an aquaponics system are limited by considerations such as the amount of light they need, the temperature at which they thrive, and their level of compatibility with the system. Number 4. Robotic dairy feed pusher. A robotic dairy feed pusher is an automated equipment that is used in dairy farms to push and distribute feed for cows. These machines are also known as robotic dairy feed distributors. A robotic dairy feed pusher's major function is to ensure that the feed in a barn or feeding area is always easily accessible to cows and is equally distributed throughout the space. By bringing the feed closer to the cows, it helps maintain good feed hygiene, it cuts down on feed waste, and it encourages regular feed consumption among the cows. Automatic feed pushers made of robotic technology are intended to function on their own, navigating predetermined paths or patterns. They are outfitted with sensors and navigation systems that enable them to identify obstructions and maneuver around them in order to carry out their duties in a secure manner. The automated feed pusher travels following predetermined lines, which are usually indicated by magnetic strips or other types of markings on the floor of the barn. With the help of a pusher blade or an auger mechanism, it brings the feed closer to the area where it will be fed or brings it within reach of the cows. The operation of the feed pusher can be configured to follow specified schedules, such as many rounds throughout the day or at specific intervals. This can be done at any time that is convenient for the user. This minimizes the amount of time that passes in between feed distributions and guarantees that the cows continue to have access to the feed. Sensors that can detect the presence of feed or other obstacles in the route of robotic feed pushers might be installed on those pushers. With the help of these sensors, the device is able to travel effectively and steer clear of any potential collisions with cows or other immovable objects. Number 3. Soil sampling and analysis equipment. The terms soil sampling equipment and equipment for soil analysis refer to the instruments and implements that are used to gather soil samples and conduct analyses of the soil's physical and chemical characteristics. The collection of representative soil samples requires a variety of tools, which are included in the equipment used for soil sampling. Among the most common types of equipment are augers, soil probes, and soil corers. Depending on the goals of the sample collection, the use of these equipment enables the extraction of soil cores or samples from a variety of depths. Once the samples have been gathered, they are normally placed in sample bags or other containers for the purposes of storage and transportation. For the purpose of preserving the sample's authenticity and warding against contamination, it is necessary to correctly label and then seal them. Sieves, soil moisture meters, penetrometers, and soil compaction testers are some examples of the types of instruments that can be used to conduct an analysis of the soil's physical attributes, such as its structure, texture, and bulk density. Number 2. Plant disease detection sensor. A sensor for the identification and detection of plant diseases is referred to as a plant disease detection sensor. Such a sensor may be a device or a whole system. Sensors for detecting plant diseases make use of a variety of technologies in order to discover the telltale signs and symptoms of plant diseases. Spectroscopy, hyperspectral imaging, thermal imaging, fluorescence imaging, and other imaging techniques, as well as detecting methods based on molecules, are all examples of common sensor technologies. Spectroscopy-based sensors examine the interaction between plants and light in order to find specific spectral fingerprints that are associated with diseases. These sensors analyze the amount of light that is absorbed, reflected, or transmitted at a variety of wavelengths in order to identify disease-related alterations in plant tissues. Images of plants are taken by hyperspectral imaging sensors, which collect a wide variety of spectral banding information. This makes it possible to conduct an in-depth investigation of plant health markers, such as the amount of chlorophyll present, the shape of the leaf, and spectral patterns associated with diseases. In the process of diagnosing diseases, it is common practice to utilize complex algorithms to examine the hyperspectral data. Thermal imaging sensors pick up on fluctuations in a plant's temperature, which can be an indication of the presence of certain diseases. Plant tissues that have been infected will frequently exhibit aberrant heat patterns due to alterations in metabolic activity and the transport of water. Number 1. Automated grapevine pruning machine. A machine that is mechanized and constructed specifically to trim grapevines in vineyards is referred to as an automated grapevine pruning machine. The primary function of an automated grapevine pruning machine is to perform mechanical pruning, often known as the removal of unneeded or excessive grapevine growth. This includes the removal of shoots, canes, and leaves from the grapevine. The practice of pruning vines is an essential component of vineyard management, as it assists in the preservation of vine health, the regulation of vine vigor, the enhancement of grape quality, and the facilitation of efficient canopy management. Cutting mechanisms, such as blades or pruning shears, are mounted on articulated arms or frameworks that are a part of automated grapevine trimming machines. These devices are designed to prune grapevines. These machines can be operated as freestanding units or mounted to tractors to undertake vine pruning chores. They move along the rows of vines and execute their work. The cutting mechanism of an automated grapevine pruning machine might differ from one model and manufacturer to another, depending on the particular model in question. It could use revolving blades, secateurs, or any number of other types of pruning instruments that are meant to create clean and precise cuts. Some of the most recent and sophisticated automated pruning machines include sensor technologies, such as cameras or laser sensors, to identify the position and form of grapevines as they are pruned. Because of this, the machine is able to precisely recognize the pruning points and alter the mechanism that controls the cutting accordingly.